Problem 4. Using rational expressions to solve a problem. Construction. Your community is building a park. It wants to fence in a play space for toddlers. It wants the maximum area for a given amount of fencing. Which shape, a square or a circle, provides a more efficient use of fencing? One measure of efficiency is the ratio of area fenced to fencing used, or area to perimeter. Which of the two shapes has the greater ratio? Well, recall that for a square, its area is side length squared, and its perimeter is 4 times the side length. We can use the second equation, perimeter equals 4s, to create a formula. S equals P over 4, where P stands in for perimeter. And the ratio we're interested in, area over perimeter, can then be written as S squared over P. We'll use substitution and substitute P over 4, which we know to be equivalent to S, in place of S in our ratio. Now our expression is P over 4 squared over P, and simplifying we find P over 16. For a circle, we know area to be pi times radius squared, and perimeter to be 2 pi times the radius. So our radius can be written as P over 2 pi. Our ratio of interest in this problem, area over perimeter, can therefore be written as pi r squared over P, and r we've established to be equivalent to P over 2 pi, so our ratio becomes P over 2 pi squared over P. Simplifying, this becomes P over 4 pi. We need to compare this to the ratio found for a square, and we state, since P over 4 pi, representing a circle, is greater than P over 16, representing a square, a circle provides more efficient use of fencing. And we can check. Assume that P equals 40 feet, so we have 40 feet of fencing for the perimeter. The area of the circle is pi times 40 over 2 pi squared, and that's approximately 127 square feet. The area of the square is 40 over 4 squared, and that equals 100 square feet. The area of the circle is greater. Your turn. Construction. Which shape of play space provides for a more efficient use of fencing, a square or an equilateral triangle? Hint. The area of an equilateral triangle in terms of one side is 1/2 times side length s times the square root of 3 over 2 times the side length s. The perimeter of an equilateral triangle is simply 3s.